Hi, and welcome to section 2.1. We're talking about samples and surveys today. What are the characteristics of a good sample survey? And learning targets here, we can identify steps to reduce error in a sample survey. We can write confidence statements for sample surveys. So confidence statement in a survey, it's basically one statement that sums up the findings of some information that you gathered, some statistic that you got. So this is a proper way to use a random digit table question. Label each card in a deck of cards 1 through 52. Use the random number table to pick 5 cards. And after you look at this, labeling it 1, 2, 3, 11, 12. Okay, not good because this has 1 digit, this has 3 digits. We need them all to have the same. So is this a proper way to use? No, they should be labeled 0, 1 through 52. So you can look 2 digits at a time. So back to the samples and surveys, population and parameter. So we've seen this before, right? We've looked at this in chapter 1, population and parameter. Population gives us something. So population, there is a number out there, and that number is called a parameter. That's the number that describes the population. This is a fixed number. We do not know this value of this number in practice, however. So this is that number out there that we can't really get to because we're limited by the sheer number of people that we need to ask at one given time, or people's opinions constantly changing about something. So what we have is the parameter comes from the population. That is the number that describes the entire population. Now, we said that there is a barrier between the population and the parameter. We can't see around that wall. So what we do is we go get a sample, a manageable sample. We get some number from the sample, and that is the statistic. So the statistic is the number that describes the sample. So as I said before, we've got this big wall between population and parameter. We can't see that number because of just practice. There's no way for us to feasibly do it. So what we do is we sample and we get some number. That number we get is the statistic, which allows us to make inferences about the population parameter. So the statistic gives us that inference, and we're using good statistical methods. We're starting to learn about those now in this chapter. So we're using good statistical methods. We're using proper randomization. We're using good techniques to get where you're asking good questions, so we can make good inferences about this. So this is known when we do take a sample, and this is going to vary from sample to sample. If you think about all the students at Buffalo High School, if you sampled groups of 50, not every single group is going to be the exact same. It's going to vary from sample to sample slightly. So the better you do with your randomization, the less that's going to vary. It's going to be less variable, but it could be slight variations from sample to sample. And this is, like I said, this is going to use to estimate or inference about some unknown parameter. So parameter and population, mind your P's, parameter and population, and your S's, statistics in samples. So the population gives you the parameter, the statistic comes from the sample. Error in estimation. So since we're taking samples, the parameter may be difficult, if not impossible, to find. That would be, a census. That's where you'd go out and you'd find the parameter. Well, we're not going to do that. There's going to be some error, right? We're sampling to get some statistic, and that's not going to be perfect every time. What it is, it's going to give us a good inference on it. So there's going to be some bias error, and there's going to be some variability. And I've got this diagram over here that we can talk about: high bias, high variability, high bias, low variability, and you can kind of see and how the pictures explain the different uses of those. So bias error is consistent repeated deviation of the sample statistic from the parameter when we take many samples. So bias error, if you think about bias, systematic over or understatement of the true value of something, in this case, our bias error, it's going to be a consistent repeated, so a systematic over or understatement of the sample statistics from the parameter when we take many samples. So we repeatedly sample, and we're repeatedly getting this overstatement. And that could be from questioning, it could be the group of people that we're asking. It could be, any number of reasons why we're getting this bias. We're clearly not using good statistical methods though. So, you've got your two high bias and high bias here with variability. Notice where these are. They're all on one side of the target. Notice where these are. They're all above the target in that case. So your high bias on those, this is going to be that consistent and repeated, your systematic deviation of the sample statistic. How do you reduce bias? Use random sampling. Random is good. Don't use, don't use those convenient samples or your call-in or your write-ins, anything like that, voluntary response. Use good random sampling, simple random samples. We'll talk about stratified random samples in a little bit, but randomness is good. Also, you can reduce, it would be a non-sampling error, but you're asking good questions. So right now we're simply talking about the act of getting the people to take the survey. We're not talking about the survey itself. So use random sampling. Random is good. Variability describes how spread out the values of the sample statistic are when we take many samples. So if you think about your high variability, they're spread out throughout. They're spread out throughout. We're not consistently getting the same or roughly the same number within some margin of error. So high variability means that the result of the sampling is not repeatable. You might ask one group of 50 some question and you might get a 20% positive rate. You might ask another group of 50 something else and you've got a 70% positive rate, and that's going to be a variable survey there. So how do you reduce variability? Use a large sample. Larger the sample, the smaller the variability. Think about asking a group of 4. One person in a group of 4 accounts for 25% of that. So if 1 out of the 4 people say no, you've got a 25% no. So one person added to that, so instead of 1/4, say it was 2/4, it's going to go up to 50%. So that's a pretty significant swing for one person. Now, let's just increase the sample size to, let's just call it 100, whereas, if you've got 1 out of 100, that's a 1% influence that particular individual has. So if you're going from 25% say no, and you increase one person, well, each person's only worth 1%, so that's going to go up to 26%. So note how it changes based on just simply adding one person. Here, you're adding 25% per person. I mean, that's a pretty big swing there. Whereas here, you're only adding 1%. And envision what that's like when you jack up your numbers to up in the thousands, or 2,000 or 10,000. So you increase it as you have larger groups. 1,000. One person's opinion has less of an effect on the overall than if you have a small group. Margin of error, this is the amount of random sampling error in a statistic. This is only with the act of getting the random sample. So how much confidence we have in our statement is going to be plus or minus some percentage from the statistic. So you're going to see something that looks like this. If you note these black dots, this is going to be the statistic that they got from running the survey. They got something. Okay, now the margin of error that you have is going to be that would be minus some percentage. So it would be minus some percentage and plus some percentage. So if you had, say, 50% answer in the affirmative, your margin of error was plus or minus 4%. That's going to be a 46 to 54%. That's your margin of error. So with 50% statistic plus or minus 4%, that could land you anywhere from 46 to 54%. How do you calculate margin of error? The quick method for doing this, it's approximated with this. There is more that goes into finding the margin of error, but the 95% confidence interval, it approximates to this. So it's the quick method of doing it. It's going to be slightly off if you went through and you did the real 95% calculation, but the thing is it's close enough that this is just a quick way of getting it. So 1 over square root of n, where as you can see there, n is the number sampled. So if we sampled 1,000 people up there, 1 over square root of n, we have 1 over the square root of 1,000, 1 divided by the square root of 1,000. This is going to give us a 3.1, let's call it a 3.2% margin of error, plus or minus 3.2%. So let's just say we sampled 1,000 people in Buffalo, and we asked, do you like chicken nuggets? And 57% answered in the affirmative. Well, what we would have is 57 plus or minus 3.2%. So anywhere from 53.8% to 60.2% would the true value would fall somewhere in there. 95% of the time, our margin of error is going to catch the true parameter. So if we did this, if in here, let's just look at this. So here's 20 samples. So a 95% confidence interval indicates that 19 out of 20 samples, or 95%, 19 divided by 20 is going to give you that 95%, from the same population will produce confidence intervals that contain the population parameter. So if we sampled 1,000 people in Buffalo, not every single sample is going to land 57%, but all of them are going to give us some margin of error. So all of them, they might be slightly different. You might get one that's a 50% to a 56.4%. But what we'll see is that 95%, our true value, our true parameter, is going to get caught by that margin of error at the 95% confidence interval, given we use good statistics sampling techniques. So a confidence statement, margin of error, it has two things. It tells you how close the sample statistic lies to the population parameter. So that's going to be your margin of error that we just talked about up there. That's the 1 over the square root of n. And your level of confidence. This is going to be what percent of all possible samples satisfy the margin of error. So 95% confidence, this is going to stay the same. This is where we live. There is a 90% confidence. There is an 85% confidence, 80% confidence. There's a 95, there's a 99% confidence. But the more confident you are, the higher the confidence level here, the bigger this margin of error is, because you want to expand your net a little bit to make sure you're catching that. So it's kind of a little give and take. 95, 19 out of 20 is pretty darn good, so we'll run with that. Confidence statement practice. In a survey to determine if the city of Buffalo should improve road conditions, 500 randomly selected Buffalo residents responded with saying yes. So we're looking at this. What's the population in this situation? It'd be all Buffalo residents. All Buffalo residents. The parameter in this situation is what we're looking for. So the true percentage, of Buffalo residents that are in favor of improved road conditions. The sample, this is going to be the 500 Buffalo residents. And the statistic is going to be what we get. Well, 275 said yes, so 275 divided by 500 is going to be 55%. So the statistic is going to be 55% here, say, are in favor. Now, the margin of error, we said 500. So 500 is our n. 1 over the square root of 500 is going to equal, 1 over the square root of 500 is going to equal 4.5%, we'll call it. So it's going to be plus or minus 4.5%. So our margin of error, plus or minus 4.5%. Now, how do you write this as a confidence statement? So the two things we need is our confidence level and our margin of error. So there's going to be a generic way that I'll have you write these. It's going to be using this specific example, I'll use as kind of a segue into it. We are 95% confident the percent of Buffalo residents in favor of improved road conditions is between 50.5% and 59.5%. Where do we get all this stuff? The red brackets up there is going to be the Buffalo residents in favor of improved road conditions. That's going to be your parameter. So the parameter is going to go here, is between, this is going to be your margin of error. So in between the blue brackets is your margin of error. So it includes the two things, our confidence interval and our margin of error. So generically speaking, we're saying we are 95% confident the true parameter, whatever we're talking about, is between some margin of error. Let's go back up here and look at what we used, 53.8 to 60.2. So we are 95% confident the true proportion of Buffalo residents who like chicken nuggets, Buffalo residents who like chicken nuggets would be here, is between, we said 53.8 and 60.2. So you can take and you can plug and play kind of whatever the situation is, and this is going to remain consistent. The part that I'm going to underline here with the purple dots, this is going to remain consistent for every margin of error or every interval confidence statement that you write. We are 95% confident the true blah is between blah and blah. So that's going to be section 2.2. So we're talking about sampling, and we're talking about error and where you get these percentages, and we can identify steps to reduce error in a sample survey. We're talking about bias error, we're talking about variability, and we can write confidence statements for sample survey.